What if our greatest reach, our grandest vision for the stars, pulled us back to the very place we fought to escape? The colossal Starship, conceived for the stars, now confronts a pragmatic anchor to our oceans, the potential shift to drone ship landings. This is no mere engineering footnote. It is a profound re-evaluation of its destiny, born from the relentless pursuit of an unprecedented launch cadence. SpaceX, with FAA approval for up to 44 Starship Super Heavy launches annually from LC-39A, faces a staggering 88 landings each year. That is 44 boosters and 44 upper stages returning from the edge of space. The elegant vision of a single Mechazilla tower catching these behemoths, a ballet of steel and sky, suddenly becomes a bottleneck for over 10% of missions. The very scale of operation demands a new kind of flexibility, dictating a need for alternative trajectories or relief from pad congestion. Thus, the ocean beckons, not as an afterthought, but as a necessary concession to the cosmic tempo. Yet, this choice carries colossal implications. Adding dozens of tons of inert mass to the Starship's structure, this translates directly into a reduction of payload capacity by 10 to 20 tons, transforming leg-equipped Starships into a specialist subfleet. Imagine the forces at play. Starship legs must endure the inferno of re-entry heat, then absorb the impact of a vehicle near 840 tons, driven by 3 Raptor engines. This is 10 times the power of Falcon 9's Merlin engines. Such impact demands more than just strength, it demands a radical shift in fundamental design. No fragile carbon fiber suffices here. Materials must shift to heavy-duty 304L or 30X stainless steel, designed to withstand impact forces many times greater than its predecessor. The engineering challenge is immense. A Starship leg system would require 6 massive legs, spanning a 15 to 18 meter footprint, built to stabilize its 100 to 160 ton empty weight on a dynamic, moving platform. These legs would need integral heat shield tiles, seamlessly merging into Starship's primary thermal protection during descent. They demand seamless welded stainless steel interfaces into the airframe, unlike Falcon 9's one-shot pneumatic telescoping legs and aluminum honeycomb crush cores. Starship's system would likely employ hydraulic cylinders or electric motors for automated extension and retraction. Upon touchdown, instant locking mechanisms, pyrotechnic pins, explosive anchors, or even energetic welding would be vital for an immediate metallic bond, battling the ocean's ceaseless motion. The ultimate cost of this compromise is measured in time and resources. Weeks for drone ship recovery from distant ocean sites, a stark contrast to the immediate restacking offered by Mechazilla. The path to the stars is paved not only with ambition, but with the heavy, unyielding reality of mass and logistics. If the very act of reaching for other worlds demands such an intricate, weighty tether to our own, what does that truly say about the limits of our unbound ambitions?